Good morning again. So in the last video, chapter 4, part 1, where we start talking about the atoms and elements, we spent a lot of time talking about the atom in terms of the protons and the neutrons and the properties and characteristics of elements on the periodic table. In this last part of the video, or in this video, we're going to talk about the electrons, their location, what they're doing, and the properties that arise because of what we know about the electrons. So I'm starting in section 4.6, which is on electron energy levels. We already said that the electrons are found outside the nucleus. They're actually found in the electron cloud. Your book then proceeds to talk about the energy levels for an electron. What we actually figure out is that the energy levels correspond to the row number. So the highest energy level for an element is usually given by what row the element is located on. Electrons do have the ability to move between different energy levels. If they absorb energy, they can move from lower energy level to higher energy level. And if they move from higher energy level to lower energy level, they have to give off that energy, and they do that. And sometimes you can see color. Depending on if your element is at ground state or excited state meaning that it has gained energy, and so now your electrons are jumping between energy levels. That will determine what its electron arrangement is. Please remember, on row 1, the maximum number of electrons you can have is 2. When we move to row 2, that number increases to 8. On row 3, the maximum number you can have is 8. And so when we start talking about electron arrangement, that's where you're telling me where the electrons are. So we know that hydrogen is the first element on the periodic table. We know that its electron is on row 1, and it only has 1 electron on row 1. And so then when we move to hydrogen, we know that there are 2 electrons. And so the 2 electrons in helium are actually found on that first row or on that first energy level. When we move on to lithium, lithium has 3 electrons. And so we know that the first 2 are found on energy level 1. The third one is found on energy level 2. So that new electron that was added to helium actually goes to a new energy level. And so it goes so forth and so on as you go across the periodic table to all the elements. Again, please remember that our periodic table is organized by atomic number, okay? Our periodic table is organized by atomic number. And when we did that, as you find out in section 4.7, there are things that we can figure out about elements based off of where they are located on the periodic table. Those properties are actually called trends. And so what we find out is with our group numbers, with our A numbers, the number that comes in front of the A, that actually tells you how many valence electrons there are. What are valence electrons? Well, they're the electrons that are in the outermost energy level. So if I'm in 1A, that actually means I have 1 valence electron. If I'm in 7A, that means I have 7 valence electrons. And what we find is that elements are trying to get stable, so they're trying to get to 8 valence electrons. Now, one way that we represent elements is using Lewis structures. And so if I were to ask you to draw a Lewis structure for an element, all you would do is take the symbol of that element, and if it's in an A group, then you would figure out how many valence electrons it has, and the number of valence electrons it has is represented by dots. So if we were to consider the element carbon, if you look at where carbon is located on the periodic table, carbon is located in column 14 or column 4A. That means that when I draw the Lewis structure for carbon, I would need to have the symbol for carbon, which is C, and because it's in 4A, I need to have 4 dots surrounding it. Now remember, when you place your dots, you need to have 1 dot on each side before you put 2 dots on any side. So for carbon, that's what the Lewis structure of that would look like. If we were to consider the element aluminum, aluminum's in column 13 or column 3A, that means I need to have 3 dots around aluminum, and it does not matter what 3 sides I put the dot on. I just got to remember I have to have 1 dot on each side before I can put 2 dots on any side. Now, when you're drawing or when you're writing Lewis symbols and figuring out how many valence electrons there are, what we find is that elements are grouped together based off of their valence electron number. And we find that if I know where the element is located on the periodic table, there are things I can determine, like the size of the element. So the first periodic trend that we're going to talk about is atomic size. And what that trend says is as I go from top to bottom down the periodic table, my elements get bigger. Well, why do they get bigger? Because every time I go to a new row, that means I have to add another energy level. And as I add that energy level, it gets bigger and bigger and bigger. Now, what we also find is as we move from left to right across the periodic table, our actual atom size gets smaller. Now, that happens because as I'm going from one block to the next block across a row, I'm adding electrons to the same energy level, but I'm also adding protons to the nucleus. Now, electrons we already know because they have the same charge. They're both negative. They don't like each other. They don't want to be around each other. But they will get closer and closer to one another so that they can feel that pull from the nucleus even stronger. So as I go from left to right across the periodic table, I'm adding that proton, and when I add that proton, they want to feel the pull from the proton. They want to feel that attraction, and so they get closer and closer together so that they can feel more of that pull. And so if I give you 2 elements that are on the same row, you should be able to tell me which one's larger, which one's smaller. If I give you 2 elements from the same column, you should be able to tell me which one's larger, which one's smaller. If I give you elements from different rows, you should be able to tell me which one's larger and which one's smaller. The next periodic trend that your book talks about is ionization energy. And when we look at ionization energy, it actually is a measure of how much energy it takes to pull electrons away from an atom. And what we find out is that the smaller the atom is, the more energy is required to pull electrons away from that atom. And so atoms with the highest ionization energy are going to be on the top left side of the periodic table. Atoms with lower ionization energy are going to be on the bottom. I'm sorry, I said that wrong. Atoms with higher ionization energy are going to be on the top right, and atoms with lower ionization energy are going to be on the bottom left. Now, one of the reasons why that is because you'll notice that at the bottom left, that's where you've got your elements that have more electrons. So it's not going to matter to me if I've got 87 electrons and you walk up and take one. That really is not going to matter to me. But if I've got 2 electrons and you try to steal one, I'm definitely going to notice. Okay. And so remember, the smaller your atom is, the more energy it's going to take that electron away. The next trend that's talked about in your book is metallic character. Please remember, the further to the left of the periodic table you go, the more metallic your actual element is. The further down the periodic table you go, the more metallic your actual element is. So again, the most metallic elements are going to be on the bottom left. The least metallic elements are going to be on the top right. After those 2 trends, your book wraps up with chapter 4, and you have your concept map of chapter 4 on page 128. You've got your chapter review information with the summary, and then you've got your questions that will help you practice with the information that's there. The answers for this chapter start on page 133. So any of the problems you try, if you're not sure of how they got something, please reach out and let me know. I'll be more than happy to help you with that. Please make sure that you're keeping up with your due dates for your homework and your other assignments that need to be submitted. Make sure that you're going to mastering and getting your chapter homework done. And remember, if you score high enough on the chapter homework, you won't have to do the adaptive follow-up. So the better you do on that chapter homework, the less likely you'll have to do the adaptive follow-up. But if you have any questions as you're working, please reach out. I hope you all have a good rest of your day. Thank you so much.